All right, curve sketching some of these polynomials. It's pretty easy. All you have to do is find the x-intercepts, or the zeros. You have to find the end behavior, which is what we did last lesson. And then you just have to draw your curve. Now, obviously it's a little more complicated than I'm letting on here, but let's do an example. Here, I have y equals negative, and then I have a term x minus 3, and then a term x plus 4, and then x minus 1, and then x minus 6. Now, this is already in factored form because it's like bracket, 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 bracket. It looks like a factored parabola, but because the degree is higher than 2, there's actually more than 2 of these brackets. The x-intercepts themselves are at positive 3, negative 4, positive 1, and positive 6. Remember that? You just flip the signs. If there was a coefficient in front of x, I'd have to account for that. I'm basically just setting each of these terms equal to 0 and then solving. X minus 3 equals 0 gives me x equals 3. X plus 4 equals 0 gives me x equals negative 4, and so on and so on. Now, I have 4 terms. This is x minus 3 to the power of 1, x plus 4 to the power of 1, x minus 1 to the power of 1, and x minus 6 to the power of 1. That's 4 terms, all with an exponent of 1. If I multiplied this out, I would end up with a degree of 4. I would get an x to the 4. If you want to FOIL these out yourself, you can, but you can trust me in that x times x times x times x gives you x to the 4, and then there are other terms that follow it. Why the degree is important is because of the end behavior stuff we did last lesson. Remember, the end behavior of an even degree is up in both directions or down in both directions, depending on the leading coefficient. Now, you may get to a point where you can identify the leading coefficient immediately. You have to watch out for these. Sometimes they'll throw tricks in here, like a negative in front of the x. But here, it's all positive x's, and then a negative out front. That negative out front means I'm going to have a negative leading coefficient. Negative leading coefficient, which means it's going to open down in both directions. So, how do we go about sketching this curve? Well, I have x-intercepts at 3 and negative 4 and 1 and 6. And I open down in both directions. What I just do for that is I draw an arrow down here and an arrow down here, just a little farther than my outer points. And what happens is I start from this arrow and I cut through that point, then I cut down through that point, up through that point, down through this point. I'm alternating the direction that I'm going in, making sure that I only intersect the x-axis at these points. It's just one big curve. Now, that should remind you of a picture you saw earlier. It looks kind of like this, but because of where my x-intercepts are, it obviously looks like this. Now, one thing I glossed over here is that by cutting straight through the point, I have implied that the exponent on each term here is 1. Now, an exponent of 1 isn't usually shown, but I've shown that I've assumed that there's no exponents here. And that's true. But it is different if there is a squared on this term here or a cubed on one of the other terms. I thought I had a better example here. Oh, I do. It's on the next page. This is a little out of order, but we're going to do this one together. What have we got? We've got x-intercepts at positive 3, negative 4, positive 1, and positive 6. Oh, those are the same x-intercepts as before. Let's plot them. 3, negative 4, 1, and 6. Now, what's my total degree? Well, I have x squared here, and x cubed here, and x, and x. That means I have x squared times x cubed, that's x to the 5, and then another x, that's x to the 6, and then another x, that's x to the 7. I'm counting up all my x's, being sure to consider the exponents here. The degree here is 7. That's odd, which means it's going to open in opposite directions, and the actual direction it ends up in depends on the leading coefficient. All my x's are positive, like there's no negatives in front of my x's, and this is also positive, which means I have a positive leading coefficient here as well. Wow, if I could spell, it'd be awesome. Positive leading coefficient. How do positive leading coefficients work for odd degree functions? Well, I haven't memorized it yet, although you should have. I'm just joking, I've totally memorized it. Opens up to the right, down to the left. Up to the right, down to the left. Note how that's different from how I placed my arrows here. Down and down. Up and up. Or up and down. Anyways, the thing I'm trying to get at here is when you have an x term that's squared, you're not going to cut straight through the x-axis at that point. It's actually going to bounce off the x-axis, similar to what you see here. This implies that you have a term with a squared on it. Something you got to memorize. I remember that because this kind of looks like a little mini parabola, and you only get that mini parabola for x squareds. X cubes also don't go straight through the intercept, and they don't bounce off. Instead, there's a little jog in the line. It still goes through the asymptote, but you're supposed to curve towards it and then curve away from it. Here's an example. You can tell this isn't a straight line. It's getting closer